This podcast is brought to you by the Creation Academy, an apologetics ministry designed to teach, train, and inspire others to become strong defenders of the Christian faith and biblical creation. Launching early 2019, the Academy offers video and audio training with downloadable course workbooks, expert interviews, and exclusive Q&A sessions with leading creation scientists and apologists, quarterly ebooks covering a wide variety of subject matter, and even a private Facebook community where you'll fellowship and interact with a like-minded community of believers. If you want to be notified when the Academy goes live and even help us design the experience from the ground up, head on over to www.jointca.co today and sign up for the waitlist. You'll get early access to the Facebook group for free as a thank you for joining. You're listening to the Creation Academy, a weekly podcast defending the truth of God's Word in biblical creation science. I'm your host, Steve Schramm, and this week we're looking at common evolutionary terms. And what we want to do is understand them. Understanding common evolutionary terms. We need to come to terms with the fact that sometimes we speak on a little bit different level, or a little bit different plane than do our do those that we have conversations with about these things. And a lot of times there's confusion. We talked not last week, but the week before last in that lesson we talked about evolution, kinds, and species. And those are three words that certainly come up quite often in the evolution debate, obviously, because that's the subject most closely associated with those terms. But there are a few other, peripheral terms, you could say. These are terms that are often thrown around in the debate and sometimes misunderstood and or not clearly defined. And I think by taking a look at those, we'll also gain a better insight into how to be more productive in talking with others. So this lesson is going to focus on understanding common evolutionary terms. The first term I want to start out with is new information. New information. Now, what we looked at a couple lessons ago is sometimes there is a distinction that evolutionists want to make between microevolution and macroevolution. And in the early days of creationism, and even really coming up into recent days, there have been certain creationists who embraced that distinction and started to use it. The problem is that they were using it in a way that wasn't really proper with respect to what it was invented to mean. And because of that, many creationists have fallen into the trap. They have begun to use this term again in a way that evolutionists don't use the term. And so evolutionists outrightly, in this case, correct creationists by pointing this out. And sometimes the creationist comes back and, and says, no, this is not right because new information is not added into the genome. And so this is a lot of times the argument, the defense that is given for one to remain using the term microevolution as a separate entity from macroevolution. But again, as we discussed a couple weeks ago a little bit, that's not a distinction that we're able to make on the basis of evolutionary thinking. And what I mean by that is the distinction between micro and macroevolution in evolutionary terms has nothing at all to do with the amount of new information that is added to the genome. There is simply macroevolution in evolutionary terms is simply microevolution happening at a grander scale. But we know from our discussion that we don't want to say that that's what's happening. In one sense, if you define evolution as change over time, then we can say that evolution is happening. But almost nobody uses such a basic primitive definition. Most everyone, when using the term evolution, really means this gradual process of unguided and undirected change. And to mean something other than that, you have to get very clear and very specific in your definitions. And so I thought it would be good then to take a deeper look at this concept of new information. And that way we can understand why the important distinction should be made between using any kind of terms that have the word evolution in it, micro or macro, whatever have you, versus using some other kind of words. Adaptation, in other words, would be a preferred kind of word, because again, evolution implies, imported into the word is this upward change in organismal life and features and complexity. It's just simply not there. We don't see that actual trend in the evidence, and so therefore we shouldn't ascribe terms to it that make others to think that evidence might actually be there, because in one sense it certainly isn't. So I want to look at this term then, new information. And this is going to be a little bit of a lengthy one, but I trust it'll be helpful for you. So scientifically, now I'm going to grab this definition here from Dr. Jason Lisle over there at the Biblical Science Institute. He has got a few good books out. This particular one I took from his book, The Ultimate Proof of Creation. The Ultimate Proof of Creation. Here's his definition of new information. Scientifically, we can define information as a coded message containing an expected action and an intended purpose. I'm going to read that again. Scientifically, we can define information as a coded message containing an expected action and intended purpose. Some of you know that my background is in technology and web design, IT, work like that. And especially as it relates to web design, sometimes I have to write good bits of code. And when code is written, one of the key concepts is to write as clean of code as possible. And what is meant by that is the more unnecessary code that you have in the system, the less efficient the system is going to run, because ultimately it will have to parse through information that is not vital to making the particular software work. Okay, and so because of that, what we want to do is anytime we create code, we want to create code that specifically causes some kind of action to take place. And when that action takes place, we want that purpose to have been accomplished. And ultimately, that's what Lisle is saying that information does. Now, he continues, because how do we make that connection between DNA? Human DNA. Is DNA really a language? Is DNA really information? I certainly don't agree with his position on evolution, but Francis Collins, most commonly known as from his association with the Biologos organization, he has said that, I think he even titled a book this, that DNA is the language of God. Now, I agree with what he's saying there. DNA is the language of God. Of course, our conclusions that are drawn from that are much different. But nevertheless, it is the language of God, and DNA is information. And let me try to defend that view. Lisle says this: DNA qualifies under the definition of information. Here's why. It contains an encoded message. The base pair triplets represent amino acids and has an expected action, the formation of proteins, and an intended purpose, life. Whenever we find any sort of information, certain rules or theorems apply. Here are two such theorems. One, there is no known law of nature, no known process, and no known sequence of events that can cause information to originate by itself in matter. And then two, when its progress along the chain of transmission events is traced backwards, every piece of information leads to a mental source, the mind of the sender. The first tells us that matter does not spontaneously generate information. The second tells us that only a mental source, a mind, can generate new, creative information. So, of course, the significance of this understanding should not be missed. What Lisle is saying here is when we look at DNA, we see a coded message. We actually see an expected action. And of course, we know that the intended purpose of DNA is life. And that tells us something very important because of the fact of number two. It's because of the fact that we know that information only originates in creative intelligence, in a mind. And then we look at this information and we put two and two together. And it really starts to look like blind evolutionary chance just doesn't cut it. As a matter of fact, and I haven't read this book, but my understanding is that this is why Dr. or Sir Richard Dawkins wrote his book, The Blind Watchmaker. Because the evidence of design is there. Now, of course, Mr. Dawkins wants to attribute that to some sort of evolutionary trait that we developed to look at things as if they were designed. But nevertheless, I think what we have here is unmistakably a pattern of design, a hallmark of design, you might say. Now, Lisle also says this, that mutations have never been observed to add brand new information, and thus they cannot be the driving mechanism of evolution. Sometimes mutations will cause a section of DNA to get duplicated, but does this really increase the information? We talked about this a few weeks ago. Do you remember the genetic duplication and reproduction, and how those processes did copy information, but they did not create new information? So Lisle continues here. By analogy, a copying error in a book may cause a paragraph to get duplicated, but surely it adds no new information. After all, could you learn anything from the duplicated paragraph that you couldn't learn from the original? Creative information cannot spontaneously increase by chance. It is always the result of intelligence. The theorems of information science tell us this, and our experiences confirm it. So if you remember the example I gave you, I said if I write, hi, my name is Steve on a piece of paper, and then right below that I write again, hi, my name is Steve. There is a second set, if you will, of information, but there's nothing new there. It was an exact copy, an exact reproduction of the first. Now, of course, natural selection in a biological sense would now have the opportunity to work on that new that separate piece of information, that copied piece of information. But at this point, evolutionists want to say that that entails the creation of new information. But this seems impossible to me, to be able to interpret it in such a way, because you can't learn anything new by just saying, "Hi, my name is Steve," twice. And if you have the same statement, if all you could possibly do is reproduce the same statement, and then natural selection can act on that and degenerate that and can change that, that doesn't make it new information. That makes it just simply lacking information. It doesn't add anything. It always takes away. And so that's what we see in the processes of adaptation. Species can adapt to their environment. I think that it would be impossible to have a world such as the one we do if it weren't for a species' ability to change. I think change is a necessary function of living reasonably in the world. However, none of that constitutes the fact that new information is added. It doesn't mean that at all. It just simply means that information was taken away, and as species change, the whole process of adaptation is the process of losing. It's losing. Now, it could be a beneficial adaptation. It could be beneficial to the organism. So, in other words, what they lose might not be a trait, but it might be a gene. They lose a gene which stops coding for a particular trait. And so it could be something that is beneficial with respect to the species in its current environment. But if you were just to rip that species from its environment, it might not be beneficial to the species proper. You know what I'm saying? If you've got Arctic wolves that were selected based on their environment and everything, and they adapted to live in the Arctic, and you stripped one out and put it in the middle of Africa, it cannot thrive in that environment. That's why when we have zoos, we have special accommodations a lot of times that have to be made for different types of animals because they are just not used to that environment. And that's the problem. That's the problem, is that nobody is receiving new information to deal with these new environments. They have a loss of information, and that loss of information, for example, allowed for that hair to grow long. And so when you try to rip an Arctic animal and pull it out into the middle of Africa, it has difficulties because of the fact that the mutation was beneficial to the organism in the circumstances in which it's found, but not beneficial with respect to the organism proper. And I don't want to get into it right now, but there's actually a pretty good argument there to be made that God actually pre-programmed through a process called epigenetics some of the adaptation and things like that into species. So that's definitely. Or I should, to be more accurate, I should say the created kinds. So anyway, so that's something to consider as well. All right. Now, Dr. Kurt Wise argues this. He says that all human languages involve at least 5 characteristics. Here are the 5: hierarchical coding, or hierarchical coding; 2, emergent modularity; linguistic structure; sending mechanisms; and receiving mechanisms. Hierarchical coding, emergent modularity, linguistic structure, sending mechanisms, and receiving mechanisms. Now, he gives a pretty thorough discussion and comparison between language and human DNA in his book, Faith, Form, and Time. And I'm just going to give you his conclusions. It's a 4-part conclusion. Number 1, at every level of structure, DNA uses codes. 2, at every level, DNA has parts that are designed to be interchangeable. 3, DNA's information seems to be arranged according to complex rules. And then 4, DNA is found within a complex cellular system designed to translate DNA information into a form usable by the cell, to create specific structures the cell needs, and to place them in their proper location in the cell. So this is a little bit more of a specific rendering of the same kind of thing that Lisle was sending. Essentially, what we've got here is a coded message, a linguistic structure that is coded hierarchically, okay? And this structure has an expected action. There's something that it needs to do. It needs to be interchangeable. It's arranged according to rules. And it's found in a very complex cellular system that is designed to translate that DNA information into something that can actually be used by the cell. And the transportation of that information is also accomplished with something called messenger RNA. Okay, and so that is all told together. The machinery behind this process is just absolutely impeccable. Certainly seems to be designed, but even more so, seems to be quite intelligent, and certainly unreasonable to think that it could have happened by itself over time. All right, just to give you another definition or two, I kind of brought this in from multiple angles because I want you to see that, more accurately, I want you to have a holistic understanding of how different scientists understand new information, so that next time you're going into this conversation and somebody says, "How do you define new information?" By the way, people have certainly asked that of me before, and I've been in a as a part of conversations where people have been asked, creationists have been asked, "How do you define new information?" And sometimes people just don't have an answer. So study this. That's why we're, of course, doing this lesson. I want you to be able to study this and understand what these answers are. The fact that there is good answers for the fact of new information, of what new information is. So you can tell somebody else what you mean by it. And then, of course, you should ask them, well, what do you mean by new information? And if they're an evolutionist, likely what they mean by new information is information that has been reproduced as a result of genetic reproduction. And genetic duplication, and that natural selection is now acting on. And as we've already discussed, that is not an adequate definition of new information, and you should be able to point that out to them. So Jonathan Sarfati says this, quote, "None of the alleged proofs of evolution in action to date provide a single example of functional new information being added to genes. Rather, they all involve sorting and or loss of information. To claim that mere change proves that such information-increasing change will occur is like saying that because a merchant can sell goods, he will sell them for a profit. The origin of information is an insurmountable problem for the GTE, General Theory of Evolution. Informed creationists do not deny that some copying mistakes or mutations can be beneficial by the normal definition that they help an organism. But in all known cases, they still add no new information." And so he uses the example of sickle cell anemia. And he says this: people who carry 2 copies of the sickle cell gene, homozygous, develop fatal anemia. But this mishapen hemoglobin also resists the malaria parasite, Plasmodium. So humans who are a heterozygous, have both a normal and abnormal gene, have some advantage in areas where malaria is prevalent, even though half their hemoglobin is less effective at its job of carrying oxygen. So you can see there's always a trade-off. And whatever way you choose to look at this, there is just no new information being added. You know, one of the worst arguments, I think, against some form of creationism is the idea that if there was a designer, he sure did a bad job. And I don't want to get into this. I've got a whole lesson planned for another time to tackle this. But when somebody says that something in the human body is designed badly, or something in nature is designed badly, it's likely that that person has absolutely zero knowledge of design work and engineering. In any design, there are going to be trade-offs. There are going to be things that work better in certain circumstances, and as a result of those things working better, there are other things that have to work worse. And so, in this case here, we do have a benefit happening to the organism in one sense, but in another sense, there is a trade-off. There's another sense in which the organism is not performing at peak function or even at the originally intended function, even if his genetic makeup allows him to be resistant to a certain disease. It's obviously a very good thing that someone be less susceptible to contracting malaria. Nevertheless, it is not good that their hemoglobin is less effective at its job of carrying oxygen throughout the body. That is not a good thing. So, what we find here is that there are a lot of trade-offs. Werner Gitt has probably one of the most iconic books on this subject. In the Beginning Was Information. And he has got a thorough treatment of information theory there from a creationist perspective. Dr. Gitt does. He states this definitively. He says there's no known law of nature, no known process, and no known sequence of events which can cause information to originate by itself in matter. Now, if you recognize that, it's because we just read that somewhere else. At the very beginning, Dr. Lisle borrowed that information statement from Dr. Werner Gitt. And so he's very adamant about this. He says that there is just nothing that causes this to happen. No matter what an uninformed evolutionist might want to say, there's just nothing that could transcend this that we know of. Now, Lisle, to kind of close out this section, Lisle writes this. I'm going to read quite a lengthy portion here. He says, a mind is not necessary to copy, transmit, or lose information, only to create it. A Xerox machine can copy information. So can a computer. A computer might even lose information, for example, if the hard drive fails. But a computer cannot generate brand new information. Even duplications do not result in new information. Suppose a computer glitch caused a paragraph in an electronic article to be duplicated, so that there are now two identical paragraphs. Do we have any new information? Could we learn anything new from the second paragraph that we did not learn from the first? Clearly not. This article will be longer now, he says, but it contains no new information from the unaltered article. And we took that from his website. Now he continues here. He says this, where did the information in your DNA come from? It was copied from your parents. You get some information from each parent, who got their genetic information from their parents, and so on until we get back to Adam and Eve. They got their genetic information from the mind of God. This is consistent with the laws of nature pertaining to information. The information in the DNA of all organisms on Earth originated in a mind, the mind of God. The information is copied by the cellular machinery, which is non-mental, and therefore cannot add new information. But some information has been lost due to mutations, and the fact that each parent contributes only half of his or her genetic code to each child. Mutations can cause duplications in which a segment of DNA is accidentally repeated, but this does not add any new information, just as a computer glitch which duplicates a paragraph does not add new information to the article. Genetics and information theory are consistent with biblical creation. You can find the entire article to which we were just referencing on Dr. Jason Lisle's website at the Biblical Science Institute. He's actually got a 2-part series there, very helpful on information theory to help you learn more about it. And so we'll be sure to place that in the notes as well, so you are able to visit that website at your convenience. Okay, I want to shift gears a little bit now to the word theory. And we don't want to spend too much time here at all because we did talk about this in a previous lesson. Um, um, and you can find that, of course, on our website. You can find that particular lesson at TCA lesson 16. Is evolution just a theory? And we will place that in the notes as well. Okay. Now, scientifically speaking, the term theory is not used in the way it is commonly understood. It's something completely different. When we think of a theory, just in general language, we think of it as something that we're very speculative of. We have just begun to think about possible solutions to a problem, or we've just come across something that needs to be reconciled in our minds, and so we develop what we might think of, what we might call a theory, in order to kind of parse that out. And what we do is we put different circumstances together in our minds and try to form a flow of thought from one proposition to the next to understand how things work. But it's just guessing. It's really just guessing. Now, scientifically speaking, that best, I would say, translates to a scientific hypothesis. So what is normally referred to in common language as a theory might scientifically be understood as a hypothesis. It is a unconfirmed guess. It is it's an educated guess, but an unconfirmed guess. It's not quite a shot in the dark. There's usually some amount of information behind the decision. It's an informed flow of thought, in other words. But ultimately, theory and hypothesis in that way are more so interchangeable. But when somebody in the scientific sense uses the term theory, of course, they do not mean an educated guess. What they mean is something that has been confirmed. They mean something that has already been through that process of tinkering and figuring out how things work. And it might not be perfectly nailed down. There might be more to nail down. But by the time something becomes a theory in the scientific sense of the term, it's fairly concrete. It's fairly well understood at that point by the wider scientific community. So I said all that to say that we don't, when we're having conversations with others, especially those who are scientifically astute, we certainly don't want to say naive things like that evolution is just a theory. People say that kind of thing all the time, not really realizing that they're giving up their position because of the fact that a theory, as science understands it, as scientists understand it, is something much different. It's a very good thing if something has made it to the point of being a theory. Now, another helpful distinction to make is the difference between a law and a theory. And again, we really parsed this out in that lesson that I just mentioned. So I highly encourage you to go back to that. And again, we'll have that in the notes. But a law, scientifically speaking, is descriptive. In other words, we observe something that happens in the universe, and a law describes that. A law never becomes a theory. A theory never becomes a law. A law is not greater than a theory. These are just two completely different things. So somebody says, maybe says something like, well, it's not like evolution is a law, it's just a theory. But again, this is, there is a sense in which a theory is even on a greater plane than a law, scientifically speaking. And so we don't want to make naive statements like that, because it shows, in that case rightly, that we don't know what we're talking about, okay? Laws don't become theories, theories don't become laws. Laws merely describe things that happen in the universe. Theories are sets of propositions which aim to explain things, and are usually pretty widely regarded by the wider scientific community. And in fact, let me give you the dictionary.com definition so we can stop dancing around it, and we'll see if their definition kind of supports what I've said thus far. It says this: a theory is a coherent group of propositions formulated to explain a group of facts or phenomena in the natural world and repeatedly confirmed through experiment or observation. Okay, so what it's saying there is it's a group of facts that work together, or rather, I should say, a group of propositions, of statements that work together, and they're coherent, so they don't contradict one another, and they explain a group of facts or a specific set of phenomena that we can observe in the natural world. But not only that, these things are confirmed repeatedly through experiment or observation. Now, I don't want to get into necessarily the middle of this battle, okay? But there are some creationists who would advocate not even calling evolution a theory. In other words, while there are some, okay, who say that evolution is just a theory, why would you listen to that? Of course, they don't know what they're talking about, unfortunately. There are others on the complete opposite spectrum who say, no, we don't even want to call evolution a theory. We want to call evolution a myth. We want to call evolution a, whatever, because it's not true, yada, yada, yada. Okay, so I understand the sentiment behind that. I do. I understand the sentiment behind that, because I think that if you really parse through the evidence, I think there is so much that cannot be explained by the general theory of evolution that makes much more sense on theistic terms. I mean, and we've talked about this, of course, namely the whole idea that science can even exist is an idea that Christians and other theists as well thought of. So, the fact that something can even be repeatedly confirmed through experiment is inherently a Christian idea. But note that is what they're going to define a theory as. So they are going to say that we can repeatedly confirm this through experiment or observation, and so therefore it becomes a theory. I think that, and we've talked about this a little bit before in different communications that I've had, my podcasts and on my blog, but I think that we need to come to grips with the fact that evolution is a decent scientific theory. Now, insofar as we're talking about evolution proper, if we leave abiogenesis out of it, if we look at evolution for what it is, as a paradigm, as a framework for understanding the world, generally speaking, it has been very scientifically successful. And I'm on pretty solid ground saying that. 97% of the world's scientists do believe in it. Now, of course, there's so much there. I mean, there are those there who are going to say that they believe in it, even if they actually don't, because of academic peer pressure. There are those who have begun to speak out against it. So, there's a lot of nuance to what I'm saying. And certainly we don't want to appeal to the majority who has been proven to be wrong in the past. So I don't want to do that. But what I do want to say is that evolution is not accepted by so many people because it is unreasonable. There is a measure in which this is a productive framework for biology. And so I don't want to say that it's, even though it might be a myth, I don't want to say, from a scientific perspective in that kind of a conversation, I don't want to say that it is a mythical thing, because that's really just disingenuous. I mean, it really does have good explanatory power. Now, the problem is that as far as I'm concerned, there's a competing and better theory. The lie that's been propagated, if we're going to call something a lie, the lie is that we must use evolution to explain the data. In other words, evolution theory is a theory. It is a interpretive philosophy through which most of the world's biological research is done. And to be honest with you, I think that's a hindering thing. And we're going to talk about that sometime in the future, I'm sure. But I think that if we were to actually begin to do biology from a creationist perspective, I actually think that the floodgates would open. I mean, I think we would actually begin to change the way that we research animal life and begin to change the way that we understand animal life. Right now, we're kind of interpreting everything mainstream scientists do through this evolutionary paradigm, and it's unhelpful ultimately because it's not the true paradigm. It's not the true history of the world, and so we're missing out on quite a bit by doing that. So just here's what I want you to get. A scientific theory is not mere speculation. Bottom line, it's just not. It's not mere speculation. That's not what it is. So we're going to move on from there. Okay, vestigial organs. Vestigial organs. So according to Webster's, a vestigial organ is a bodily part or organ that is small and degenerate or imperfectly developed in comparison to one or more fully developed in an earlier stage of the individual in a past generation or in closely related forms. So essentially, these are things that show up later in the, just to use their terminology, later in the so-called evolutionary process. And they are supposedly a remnant of the way that an organism, the kind of structures that the organism once had to survive in a different environment, different time period, etc. Now, I want to start out this section certainly by saying this. Vestigial structures do exist. Let me repeat that again. I want to make sure that you've got your ears open. Vestigial structures do exist. To claim that they don't, in my view, would just be playing unfair with the evidence. You know, this is where when an evolutionist comes in and says we can observe things about evolution, this is one of the things that they're going to point to is vestigial organs and vestigial structures. And many a creationist has just, said, no, these things don't exist and the pictures are made up and this, that, and the other thing. Look, certainly, evolution is fraught with fraud. Say that 5 times fast, okay? Evolution theory throughout the centuries has been fraught with fraud. It really has. But that is not to say that we must think of every challenging solution or every challenging piece of information that evolution theory presents us with is fraudulent, because it's just simply not. Some things do exist, and we need to ask the right question. We need to ask not why these things exist. We need to not jump to the conclusion that they really don't and that there's some kind of nefarious activity going on. What we need to say is evolution the best explanation? But we have something here that is happening. No question. We can see it. It's happening. Is Fichte philosophers' Darwinian evolution theory the best explanation for this? Now, many people just don't even question that. So there's one level of problem. Many people just don't even think to question that part of the proposition. It's kind of like the whole issue of time. If we have discordant dates with radiometric dating and things like that, we don't even think to question the time. At least mainstream scientists don't, because that's just the paradigm. You don't go outside of the paradigm to understand something, and so that's what's happening oftentimes here. The question is just never asked: is evolution the best explanation? Now, Dr. David Menton, with Answers in Genesis, has argued that while these structures certainly do exist, they do not necessarily require evolution. And I want to give you a couple things that he wrote in an article on the Answers in Genesis website. So first, he says that the definition has changed. The definition has changed. Let's look at this. As the state of functionless organisms, has grown smaller and smaller with advancing knowledge, the definition of vestigial organs has been modified to include those whose functions are claimed to have changed to serve different functions. But such a definition removes the burden of proof that vestigial organs are a vestige of evolution. Thus, the evolutionist might concede that the human coccyx, or the tailbone, does indeed serve an important function in anchoring the pelvic diaphragm, but still insist, without evidence, that it was once used by our ancestors as a tail. So, basically what he's saying there is over time, there are things in our body that were thought to be absolutely useless that upon further investigation, it appears that there is a very specific use case for them now. And so vestigial organs or vestigial structures, the definition of that has changed to be able to include those things so that we could say that while they may have usefulness now, they might have also had usefulness in the past to do something else or to perform a different kind of function. And so this is what I was talking about just a moment ago. The problem is that you can't falsify this because it's a moving target. The interpretation is done according to the paradigm. The paradigm itself is not questioned, you see. So when it turns out that something that we once thought was purely a vestigial structure actually did have a modern use case, when we find that out, the best question would be to ask, oh, okay, well now that we know that, maybe this lends some credence to the idea that every organ in our body has a specific function, and maybe it was always intended to function that way. But see, no. As long as the data is interpreted according to the paradigm, then we're going to always have to go back and say, but what did this mean in our evolutionary theory? In our evolutionary past, what did this mean? Rather than to say, did we really have an evolutionary past? So much of the information that is propagated about evolution theory does not take the time to think through that part of it, and does not take the time to tell students that you can question things and think through that part of it. You don't have to interpret through the paradigm of evolutionary theory just because. There is no law that says that. So that's what we want to get people doing here, is thinking about things and really thinking critically and carefully about the kind of claims that are made versus the kind of facts about reality. Okay, so he says he takes time to mention vestiges then of embryology. He says there are several structures that function during the development of the embryo and fetus that appear to be no longer used after birth. So these things exist. Remnants of these once functional structures persist throughout life. Such structures perfectly fit the definition of a vestige, but they're not vestiges of evolution. So you see what's happening there. He's saying, yes, we do have vestigial structures, but just because it is a vestigial structure does not mean that it is related to the evolutionary process. In this case, it's just related to the process of the production of life, the development of sexual dimorphism. He says almost every organ of the female reproductive system can be found in a different or vestigial form in the male reproductive system and vice versa. For example, in the male, the prostatic utricle and outpouching of the prostatic urethra having no known function is a remnant of the paramesonephric duct that develops into the uterus and oviducts of the female. Clearly, the vestigial organs of reproduction are not a result of evolution, but rather embryological development. Now he comments on homology. He says many vestigial organs are examples of homology, but not necessarily of evolution. Homology is an underlying similarity between different kinds of animals recognized by both evolutionists and creationists. All terrestrial vertebrates, for example, share a widespread similarity, homology, of body parts. Evolutionists insist that this similarity is the result of evolution from a common ancestor. Creationists, on the other hand, argue that this similarity reflects the theme of a common creator and the need to meet similar biological requirements. And so that, this is just reasonable common sense stuff. You've heard the old, we've got two eyes, we've got two ears, we've got four limbs. We share many things in common. We are mammals under that scientific definition. We share many things in common with animals. Does that mean that we are an animal? Well, according to evolution theory, that's exactly what that means. But that's not what the Bible says about us. And the Bible, of course, has no problem making the distinguishment between humans and animal life, and yet says that the same creator is responsible for creating all of them. So we have an explanation for this. Again, there is not a need to default to this evolutionary paradigm, not when there is a good creationist explanation. Now, so this kind of tells us a little bit about what we could actually consider a vestigial structure. But Dr. Wise gives us a helpful contrast in what this term means for evolutionary theory versus creation theory. This is very helpful, I think. So he says that in bioevolutionary theory, organisms are continually changing, evolving new structures and phasing out old structures. Vestigial structures are evidence of this evolution, at least of the phasing out of old structures, and should be common features of life. So that would be how to understand a vestigial structure on the evolutionary paradigm. But here's what he says about it on the creation theory. He says, in young age creation theory, many intrabarometric changes have occurred, including the loss or partial loss of structures. By the way, just for review purposes, if you are not sure, a Brahman, is a created kind. In the Bible, it says that they will bring forth after their kind. The word "kind" in the Hebrew is men, and the word for to create in Hebrew is bara. And so Frank Marsh in 1941 coined the term Brahman to kind of explain this. And Drs. Kurt Wood and Dr. Kurt Wise. They are two of the leading creationists who are doing work in this area. All right, and so an intrabarometric change would kind of be like adaptation. It would be a change within a created kind. Okay, that's going on. All right, so furthermore, with the fall, I'm quoting again now, imperfections began entering the system, causing some structures to lose all or partial function. Young age creationism suggests that these changes occurred within the last few thousand years. This means that in most cases, change has not eliminated all the information to build those structures. Thus, the occasional genetic throwback, that is, the rare occurrence of a multi-toed horse, for example, and the ability to produce all or part of a long-lost structure, such as the development and resorption in some unborn sperm whales of bones for a rear leg and hip, is easier to explain in young-age creationism than in evolutionary theory. Isn't that interesting? Now, Wise concludes from that the existence of vestigial structures and genetic throwbacks is more easily explained by young-age creationist claims that it occurred only thousands of years ago, rather than conventional claims that it occurred tens of millions of years ago. Since intrabarometric diversification is recent, it also explains why interspecific hybridation is common. It is much easier to explain successful hybridation after only thousands of years of separation than it is to explain compatibility after millions or tens of millions of years. And so here we have a case where, in fact, something that is considered to be one of the death knells to young age creation theory is actually much better explained within young age creation theory. So, with all of this considered, I say that therefore, the best course of action here is not a denial of these structures. It is not. It's not a denial that vestigial organs exist. There may be some spirited debate over what should actually be considered a vestigial organ, and certainly the differentiation should be made between what one might think of as an evolutionary vestigial organ versus a reproductive vestigial organ, so on and so forth. But nevertheless, we don't need to deny writ large that these exist. And perhaps we don't even need to deny them as evidence for evolution, because they could be. We know that evolution didn't happen, but ultimately we know that from the biblical revelation. It could be that if evolution had happened, the vestigial organs are the kind of thing that we would want to see. So I don't think there's a problem with denying that these are evidence for evolution. Rather, the best solution may be to simply demonstrate how these are actually more welcome in a creationist understanding of the past. Because what you're going to be doing here is taking something that the evolutionist likely thinks is going to just be the death knell. I mean, they think they are getting ready to knock you out with the mention of vestigial organs. But see, you've already thought about that. And you've already considered how these are actually easier explained in creation theory. Now that is how we craft a response. Very quickly, I want to give you the last thing, and we're going to go a little over an hour today in this lesson, but this is an important one, so we most certainly want to get this out. Transitional fossils and forms. Transitional fossils and forms. Now, these can be defined, and again, I'm going to use Kurt Wise here pretty much for most of this section because I really liked his explanations for this. But we can define it like this. Organisms developed during the transformation from one group of organisms to another. Formed during a transition, they begin after the first appearance of the ancestral group and before the first appearance of the descendant group. They would be expected to have a body form intermediate between the body form of the ancestral and descendant groups. When preserved as fossils, transitional forms should show up as stratomorphic intermediates. Fossils intermediate in body type and rock position between ancestral and descendant groups. So we're looking for something very, very specific. And although this is not necessarily the time to talk about it, we are going to touch on it a little bit because of Wise's descriptions here. What you'll find is that this is an area that is extremely, extremely lacking for someone who would not want to affirm a creationist understanding of the world, that is, with the flood of Noah having occurred. Because in a very real sense, there is not very much evidence along these lines that is helpful to the position of the evolutionists. So let me give you just a few things, again, from Dr. Kurt Wise. He says, in his comparison, in bioevolutionary theory, all organisms are thought to have evolved from other organisms. Transitional forms should have been produced during the origin of every type of organism. According to the same theory, the fossil record has been preserving organisms during virtually all of Earth history. Consequently, stratomorphic intermediates should not only be common, but should be found in nearly every rock layer and associated with nearly every type of organism, especially easily preserved groups. Now, of course, by contrast, he says in young age creation theory, change occurs within the created kinds, Brahmins. Because God designed most of the body forms into the system at the beginning, many species have originated without transitional forms. Few transitional forms between species may have ever existed. Furthermore, in the young age creation model, the fossils in flood sediments preserve a snapshot of the organisms living on Earth the day the floodwaters reached them. Because of this, transitional forms would be extraordinarily unlikely in flood sediments. On the other hand, rising floodwaters may well have preserved organisms in the order they were encountered. So, if adjacent pre-flood communities had intermediates between them, such as mammal-like reptiles living in a zone between a mammal-dominated community on one side and a reptile-dominated community on the other, then stratomorphic intermediates might be expected between these two communities. Stratomorphic intermediates then should be rare in flood deposits, possibly primary and secondary, but when they are found, they should be ecological intermediates between adjacent communities. Post-flood sediments, possibly the tertiary and quaternary, were deposited during the period of highest intrabarometric diversification. In these sediments, one might find stratomorphic series of fossils documenting intrabarometric diversification. I can't talk. Of fossils documenting intrabarometric diversification and reflecting the cooling and drying climate of the post-flood world. So, something else I want you to see here is that a term like this, transitional fossils and forms, these are things not to be scared of. They are something observable. They are something that we are able to look at and understand. The question is then, what are the nature of these things? Do these things serve to confirm evolution theory, or do they actually work better in creation theory? And I think so far from what we've seen, the actual evidence we've seen, they work better in creation theory. Evolution is inadequate to explain these things because they don't show up in the way that they ought to if evolution were to be true. In a popular blog post, this is not a scholarly paper, Dr. Todd Wood has claimed that, quote, as a young age creationist, I'd have to confess that interbarometric intermediates are likely to be Brahmins themselves and are therefore attributed to creation. I say this with one reservation. Some Seventh-day Adventists, like Harold W. Clark in his 1940 book, Genes and Genesis, believe that these intermediates are confused species that arose by interbreeding of created species. I will, however, proceed on the assumption that this perspective is incorrect. Like Frank Marsh, I find the notion of reptiles and birds crossing to produce Archaeopteryx incredible, in that interbarometric intermediates were created by God. So Dr. Todd Wood takes a stance on that he thinks that some of these things that are interpreted as interbarometric intermediates, that is to say that they are an intermediate, they appear to be an intermediate form between one Brahman to another, one created kind to another. He said they're very likely to be Brahmins themselves that are actually just creations of God. Now, that's not to say that creatures don't change and adapt. That's not to say that at all. That's just to say that what one might think of as a transitional form would actually just be its own its own Brahman, its own created kind. So, to put it this way, in other words, his view asserts that while some of them are likely to evidence real genealogical relationships within Brahmins, other work he has done has led him to find consistently that archaeocetes are not intermediate between terrestrial mammals and whales. And so because of that research, that has led him to extrapolate that idea further, and he's doing more research on that quite literally as we speak. Even as I say that, though, there's much more work that needs to be done in this area. Will you take it to task? Will you become the next Dr. Kurt Wise, Dr. Todd Wood? Dr. Jason Lisle, Dr. Werner Gitt? Will you become the next one to take up the mantle of scientific learning and advocating for the reasonability, the reasonableness of creation science? I think maybe you should consider that. I want to conclude in the words of Frank Sherwin and Brian Thomas. These are two staff members of ICR, of course, the Institute for Creation Research, and they work for them, and they wrote this article titled "Beware of Dangerous Definitions." Certainly a fitting title. And here's what they say, quote, "Often it is more effective to discuss definitions by asking for them rather than by stating them. If a person uses any term, it is incumbent on them to be able to explain what they mean by it. Asking for an example of it is also fruitful. When explored with respect and deference, this tactic can move a conversation in a positive direction and perhaps open someone's eyes to the possibility that a scientific-sounding term might describe a process that is not based on science, but rather, at least partly, on an unfounded presupposition." Close quote. And I love that statement. As we tell you here to do all the time, ask questions. Somebody says a word. What do you mean by that? Somebody states a conclusion that they've made. How? You ask them. How did you come to that conclusion? Because it's likely that they might not have done much research on it at all. And so you can help by gaining the proper definitions, and I hope this lesson series has helped you with that. By gaining the proper definitions and by understanding how words are meant to be used, how they were used historically, and how maybe even those definitions have changed over time, you can begin to have even more productive conversations with those with whom you disagree, and maybe even have a chance to lead them as a result to Christ. What a blessing and an honor that would be. Let's pray. Dear Heavenly Father, we want to thank you for the time to go through this series and to learn about the way that definitions have been used, and about how we can be more astute in having these conversations with others. Lord, thank you so much for your word and your world. Thank you for allowing us the ability to know you as our Savior. Thank you for the ability to explore and to subdue your creation, Lord, to learn more about it, to help it, to help this creation achieve its purpose for which it was created, Lord, and help us to achieve, Lord, our purpose, to know you, to glorify you, Lord, and to enjoy you, certainly, forever. In Jesus' name we pray. Amen. I want to thank you for joining me this week here on the Creation Academy. This has been a fun series dealing with common evolutionary terms and dealing with worldviews and evolutions and species and science, what we mean by literal creation. We've dealt with many different things and so many different topics over this series, but we certainly appreciate your attentiveness to it, and share this with your friends if you'd like. We would appreciate if you would go and leave a review on iTunes, if you would share this with somebody else, tell somebody else about it. We want to grow a community, a large community of informed creationists who are really doing good work out there for the Lord. He deserves our best. He gave us the very best, and so we certainly ought to give that to him as well. Thanks, God bless, and we'll see you next week.